This podcast is brought to you by ProcessBarron. Handle everything better. Welcome to Powering the Process, the podcast focused on the real work behind industrial manufacturing. Each week, your host, Jen Little, digs into the systems, equipment, and strategies that keep plants running efficiently. From everyday operational challenges to emerging engineering solutions, we're here to share practical insights that help you keep your process moving. Let's get started.
What if the garbage we throw away every day could actually power our homes tomorrow? Welcome to Powering the Process, where we uncover the innovations shaping the future of industry. In this episode, we're diving into waste to energy, a technology that turns trash into a valuable resource. ProcessBarron plays a critical role in making this transformation possible. From designing and installing systems that move fuel and ash efficiently to optimizing air and gas flow, they help waste-to-energy plants operate at peak performance. It's all about reducing landfill waste, generating clean energy, and creating a more sustainable future. Today's guest is Ashley Doyal. He has been with the company for almost 32 years, and he currently serves as Vice President of the South Region and Central and South America. Thanks for joining, Ashley.
Well, thank you, Jen, for having me. I'm looking forward to our discussion.
Oh, me too. I'm so glad you're here today. So we're going to talk about waste to energy and the parts that ProcessBarron plays in that industry. So just some general questions. What are the environmental benefits compared to traditional waste disposal?
Well, your traditional waste disposal is really landfill. Probably about 50% of your municipal waste goes to landfill. So by using waste to energy, producing electricity, you decrease the amount of garbage that goes into the landfills themselves. Decreases greenhouse gases because landfill, during the decomposing process, produces methane, CO2, which affects the greenhouse gases.
Mm-hmm. So what misconceptions do you think people have about waste to energy plants?
Probably the biggest is that it's harmful for the environment. The waste to energy plants are heavily regulated. And what you see going out of the stack at a waste energy plant, about 99.9% of what's going out of that stack is oxygen, nitrogen, and water vapors. So it's very clean. Once you keep the air pollution control devices up, maintain them, it's really safe for the environment. And once again, reduces what goes into a landfill.
So what specific equipment or solutions does ProcessBarron offer for that industry?
We offer a wide range of equipment, all the way from the air handling equipment, which is when you have a boiler, it's a balanced flow. You're by putting oxygen into the furnace using the FD fan, and on the back side of the boiler, taking the oxygen gases out using the ID fan. So that's a balanced flow, getting the combustion cycle inside the boiler itself. We also do all types of air pollution control devices. We work on the spray driver absorption systems. We work on the precipitators in the baghouses in those facilities, as well as the ash system, which is, once again, once you burn everything, you have to have ash coming out. And on the bottom of the precipitator or baghouse, you'll have dry ash collected, and we can handle that, getting it off-site.
All right, so Ashley, what are the biggest operational challenges in the waste to energy plant?
The biggest operational challenges are, one, getting the waste into the boiler itself. It's a very cumbersome process, labor intensive, but also just really the maintenance, the upkeep of it, the maintaining all the air pollution control equipment to make sure you're meeting emission regulations to be able to keep the facility running. If you're looking at the front end, the biggest investment, of course, is building a new plant. A new waste energy facility can cost you probably just an average size, $500, $600 million to build.
So we talk about burning garbage. A lot of times we call them garbage burners in the industry, and waste to energy is the nice way to put that. But when we talk about that, we're saying that trash or garbage is the fuel, obviously.
Correct.
But is there a limit to what that is? Are we talking about household waste? Are we talking about construction waste? Are we talking about anything anybody throws away? size-wise or what it's made of?
So you can't throw your refrigerator away and it's going to get put into the boiler, but it is most of your household waste and office waste. Your typical wood waste from carpentry waste, it'll go to a biomass facility, which strictly burns bark / wood waste.
Right.
The garbage burners, they burn really your household garbage. It's unprocessed, plastics, glass, anything you have will go into the furnace itself. And then, of course, your glass will not burn and it will come out into the ash system itself. If you look at it, the average person produces 5 pounds a day of garbage. That's over 290 million tons in the United States of garbage every year. The waste-to-energy plants that burn the garbage can, say if they burn about 2,200 tons per day, that facility can generate enough electricity, about 40 to 60 megawatts, to basically provide power to about 15 to 20,000 households.
That's amazing.
It is.
It is. So are these facilities mostly owned by municipalities?
There's a combination of both. A lot of them are owned by municipalities, are in conjunction with a larger waste-to-energy company who either will own it and operate it or just work for the municipality as an operator. That would be a long-term contract as the operator of the facility.
Okay, that makes sense. I know at one time the largest concentration of those were in the state of Florida.
Yes.
Seemed like that's where it kind of started, got going. So how has that changed in the last few years?
Well, it has. There's still quite a bit in Florida and up the East Coast, and it's really the population density. If you think about it, it had to start in Florida with everybody retiring in Florida. Garbage just keeps collecting.
More people, more
garbage. And but up on the East Coast, your cities are very heavily populated. Also, the transportation. We can get into later on different types of hazardous waste that may be burning, whatever. There's a few facilities that specialize in burning hazardous waste, but then you have a transportation cost. It costs a lot of money to get it from California to the Midwest or even to the East Coast. So transportation cost is a big factor.
So how does ProcessBarron address issues like corrosion at a place like this? Because if the fuel is all of this garbage and they can't necessarily regulate what's in it. Maybe the big things, like you said, the appliances, things like that are in it.
Taken out.
But is there a screening process going in at some point, or how does the fuel handling system maintain integrity?
Well, the fuel handling system is pretty much a clamshell with a big, in mass burning. It's just a huge mass burning facility. They take all the bigger pieces out well before it gets into this process. But once again, your plastics, your steel, glasses, batteries, everything you're putting into your household garbage is going to make it through that and get into the boiler itself. As far as corrosion, there's different coatings on the back end. When you have the ash system, you can look at stainless steel, depending on how corrosive it is coming out of the boiler. But most of it's going to be inside the boiler with the boiler tubes, etc. And they'll use different materials on coatings for the boiler tubes.
Well, we kind of touched on this a little bit. So looking at the future outlook of waste to energy, how do you see that evolving in the next decade? And do you think that it could become a major contributor to the circular economy?
It needs to become a major contributor to the circular economy as far as basically promoting the use of materials, getting materials out of the ash, getting the steel, whatever makes it through the boiler, it can actually be recycled. So that's one thing the waste energy plants are looking at doing, is trying to make sure they are part of the circular economy. As far as the long-term outlook of the waste energy, I'd say within the next decade, it's going to be exponential of how many plants they have to build. If you look at it, in the U.S., we generate 3 times the amount of garbage than any other country. So to be able to keep up with it, either landfilling it or burning it, more facilities are going to have to be put online to take care of the garbage.
Okay, so in the past, I think there's always been incinerators, but so that method was just to simply do away with
Correct.
the garbage. where waste to energy is actually converting it?
Well, it's twofold, because when you're just burning it, you're also putting gases in the atmosphere. By having a waste to energy facility, you're controlling your emissions as well as producing energy. So once that garbage is burned, your steam, a high pressure steam from the boiler, goes to a turbine, which then goes to the generator, produces electricity. And once again, if it can produce enough electricity for 15 to 20,000 households, that's not energy you're getting from the fossil plants or any other power producing facility.
So, all right, thinking about ProcessBarron's role in the waste to energy industry, can you think of anything that makes ProcessBarron solutions unique?
Really, the unique aspect we bring to waste to energy is the different products, the engineering we can offer, the different things, solutions we can do. We do the air pollution control devices, we do the precipitators, we do the baghouses. We've done several large projects of replacing baghouse modules to get them back in compliance, make sure they're meeting EPA regulations. But we also do the fans. We did a project down in Florida where we actually did a fan efficiency upgrade. The fan was running about 35% efficient. We did testing on it, resized the rotor, and able to get them probably above 7% efficiency, which helps them save their own electricity that they're utilizing to power their plant.
So they are mostly self-sufficient, so they're not all just supplying energy to the cities around them, but they're producing enough energy in order to run.
That's correct. They're producing their own electricity. They are subsidized by the local power plant. They do have lines coming in when they do need power, but they're producing enough electricity to provide that for their whole system as well as putting it onto the grid.
Okay, that's amazing. So do you have any advice, I mean, ProcessBarron looking out, do you have any advice to municipalities considering a waste to energy?
Yeah, you need to evaluate your strategic and financial the viability of a new plant. Once again, I said it could be 500, 600 million and upwards to build a new plant. You need to look at the viability of what are you doing with your waste right now. So every municipality is collecting the garbage. Taxpayers are paying for it. You have to get rid of it somehow. The viability of transporting it to a different city, you're paying that city to take it. The viability of landfilling, the amount of land you have. We talked about Florida earlier. Florida and around the big cities does not have a lot of land to really put in new landfills. So building these new facilities will alleviate a lot of the garbage and produce electricity to support local municipalities.
Ashley, how does waste to energy reduce landfill dependency?
Well, once again, by taking the garbage, taking it to a waste to energy facility and burning it, it alleviates how much waste is going into the landfills. Now, some of the ash that is collected does still need to be landfilled. But if you landfill some of the ash, and some of it's also used for cement-based products as well as asphalt. But if you're landfilling that ash, it's about 10% of the volume, that amount of garbage. So still a lot less of land that you're using for the ash itself. But by alleviating a lot of what goes into the landfill, and you're producing electricity, and you're helping greenhouse gases, because once again, when the garbage is decomposing, it's producing methane, and which is a greenhouse gas.
What steps are taken to minimize emissions during the process?
There's several different processes that the facilities use. One is spray dry absorption, which is injecting hydrated lime into the system, and it has a reaction with the acidic acids, making them neutral. And then downstream, you'll also have the either a baghouse or a precipitator. And those are three items we've worked on at several of the waste energy facilities in the United States, replacing the SDA cones, baghouse modules. We have maintenance crew doing all types of maintenance, rebuilds on precipitators as well. That's the three primary things. And typically they won't have a baghouse and a precipitator, be one or the other. But on the SDA, that is the primary means of getting the emissions down. They also do CEM systems, control emission monitoring systems at the stack, which is monitoring everything going through that stack. Once again, everything is most of the time clean coming out of there, even though most people don't think it is. And that's heavy regulated by the environmental agencies in each municipality.
Well, I know that our presence at waste to energy plants, I feel that's going to increase over the next few years. Obviously, as more plants are created, then our presence will increase as well. I'm looking forward to see what else we can do in that industry.
Well, in the new facilities, as well as the ones that have been running for years, because those, they need upkeep, they need maintenance to be able to make sure they stay within the EPA guidelines.
So do they have the same maintenance schedule like some of our other customers in the, pulp and paper, cement, steel? Are they kind of on a yearly maintenance?
They are on a yearly maintenance. However, most of them will have multiple boilers. They will not take them both down at the same time because they have to be taking in garbage from the municipality. So they'll take one down, do all the maintenance on it, have it up and running so they can continue to take garbage in before they shut the other ones down.
Mm. Well, that makes sense. That definitely makes it better on us, right?
Yes.
Yes. Well, Ashley, I really appreciate you being here today.
Well, thank you, Jen.
And kind of giving everybody a better education on waste to energy, how that works, and what part we play in that.
It was my pleasure. Thank you very much, Jen.
Of course.